the pair of linear equations in two variables. Previously in 9th class, we have studied what? About linear equations. Shall we recall it for some time? See, the linear equation is in the form of ax plus by plus c is equals 0, in which a square plus b square not equal to 0. Oh, then that means that a and b not both 0 at the same time. We have discussed this in the brief. So this is a linear equation in two variables, that too in two variables. Only one equation is there. Okay. Here we are about to see pair of linear equations. So two equations likewise. Now we see some characteristics of this equation. This equation used to denote a straight line in the graph. That is why this equation itself called as linear. This line is silent here, is it? Okay. So it used to denote a straight line. Okay, when we talk about lines, there will be infinite number of points on it, right? As many points, that many values of x and y we have. So the thing is, whenever we speak of equations, we speak of solutions. Solution means the value of that particular variable satisfies the given equation. Is called solution of the linear equation. So this equation has this denotes straight line in graph. This equation has infinite number of solutions. Whenever the value of x is given, the corresponding value of y we can say. Remember, we have seen like 2x plus 3y is equals 5. This kind of equation has various number of solutions, is it? If you replace x as 1, we will get corresponding y value. If we replace y as 1, we get corresponding x value. As many values we replace, that many values we get. Infinitely many solutions we may get. That is how this straight line works, and then this equation works. And this part is really important. A square plus b square not equal to 0. Why? Because they are not 0 at the same time. This only will happen only if both are 0. Is it or not? That is why this one. Now coming back here, the pair of linear equations. Means two such equations. We need to differentiate them. How we can differentiate? Instead of a, b, c, if I am writing ax plus by plus c is equals 0 is the first equation. Second equation also ax plus by plus c is equals 0. Isn't it the same equation? Yes, they are. So we need to differentiate. For that, a1, b1, c1, a2, b2, c2. Okay. Likewise, two different equations. So this represents how many lines in the graph? Two straight lines. This represents two straight lines. Okay. And speak of this condition, this a square plus b square. That means the coefficient of this equation will not both 0 at the same time. For each equation, it is separately you can write like a1 square plus b1 square is not equal to 0. For this equation, a2 square plus b2 square not equal to 0. Okay. So whenever we say a particular point is a solution of the equation, that means that that point lies on the particular equation. Sorry, particular line. Then we call it as a solution of the equation. Got it? For example, here when you replace x is equals 0, y is equals 5 by 3 we may get. The point 0, 5 by 3 lie on this line representing this. Okay. To check whether 0, 2 by 3 lie on this line or not, we'll substitute this point. If we got 5 means it lies on the equation, it satisfies the equation. Suppose it is not means it is not lies on, it does not lie on the particular straight line. As we speak of here, two lines. The two lines have three possibilities. What are all the possibilities we may have? The possibilities are either the two lines may intersect, are the two line, the types of line. Either the two line may intersect. Intersecting means at one point. Okay. Or the two lines may be parallel. Sorry. Or the two line may be coincide on each other. They lie one on another. Okay, these are the three possibilities. So here we said like infinite number of solutions, right? So this pair of solution means the solution of this pair means it should satisfy this equation as well as this equation. So by the previous theory that this guy has infinite number of solution, this guy has infinite number of solution. So if all the solution satisfies both the equation, all of them we can say. Or the point of intersection, that means only one point is common. Then this particular point is called a solution. We call the type of solution as unique solution. That we can name it as algebraic interpretation. Unique solution or only one solution, exactly one solution. Okay, so here both will have same common point. Here does this line have any common points? Do they have any common points? Look at the diagram and answer. No, they don't. That means this system has no solution. And coincide lines lies one on another, meaning all the points are same. Then how many solutions it may have? Infinitely many solution. Okay, shall I erase this side? Now we got to know what is pair of linear equations and then what kind of solution it may have. The thing is that we should always draw the graph to figure out what kind of lines they are. Is it? How to draw the graph, how to find a solution, all we'll see in further. But the point is to check whether the particular two equations have what kind of lines, means you should draw the graph of each equation. For example, here you take one example of the equation. They say x plus 2y is equals 5 and then 3x plus 7y is equals 7. This kind of two equations we may take. A particular value of x and y satisfies both the equation is called the solution of the equation. Okay, we should draw this as a graph and then we figure out what type of solution they have by seeing the graph, whether it is intersecting or parallel or in coincide. It is not works all the time. Is there any shortcuts for that? Yes, it is. The shortcut is we take the ratio of the coefficients, x coefficient, y coefficient and the constant term. The ratio of the coefficients a1 by a2, b1 by b2 and then here a1 by a2, b1 by b2, c1 by c2. Shall I erase this part? You know this example as well, right? Am I audible? You guys are not audible. Am I audible? Okay, just a minute. Am I audible now? Speak something. You guys are not audible to me. Speak something. Am I audible or not? Unmute yourself and speak. Ah, yes. Now you can audible. Now you're audible. Okay. See, this ratios we have to compare. The ratio is A1 by A2, B1 by B2, C1 by C2. Now listen to me carefully. Here, the lines are intersecting, right? And we have exactly one solutions. Just pause writing for a moment and listen here. See. Consider this equation sign as two lines. Okay. When they say intersecting lines, this ratio will also be not equal. That is the intersecting line passed through this equation. Okay. That is A1 by A2 not equal to B1 by B2. And then here, no solution. They are parallel, right? Now listen carefully. These two lines will be parallel. And after that, this will not be equal. First parallel and then it will not be equal. And then here coincide, fully same, equal to, here also equal to. Okay. In this way you just relate, or else you have some better way also you can relate. This way you can relate, so to avoid confusions. Got it? So previously I gave one equation, you remember, that is x plus y equals 5, x plus 3y equals 7, I guess, is it? Whatever. Now we are going to determine what kind of solutions it is going to have, what kind of lines it is going to have in a graph. So how we can determine, find the values of the coefficients. So it is 1 by 1, a1 by a2 and b1 by b2, it is 1 by 3. Are they equal? This a1 by a2 not equal to b1 by b2. So not equal to. What kind of lines? It is having intersecting lines and it is having unique solution. Okay. And then next, speak of consistency. Consistency means if there is a solution exists. If there is a solution exists, we say these two equations are consistent. If there is no solution exists, it is not consistent. So look at here, we have exactly one solution. The solution does exist. So that means it is consistent. Okay. And then look at here, we have no solution. So this is not consistent. And then here we have infinitely many solutions. Having one solution itself consistent. Infinitely many also. Shall we say infinitely consistent? No. Consistent. That's all. So this is consistent. Now what kind of system it is? Is this a consistent system or not consistent system? It has an intersecting line, meaning you have one solution, then it is consistent. Okay. Any doubts on this? Now watch clearly. The another set of equations, that is, let us say x plus y, x plus y, x plus 2y equals to 8. 2x plus 4y is equals to 16. What kind of solution this equation is having? Here first ratio 1 by 2, this ratio 2 by 4, this ratio 8 by 16. Okay. So this all the ratios are equal, is it? Everything is 1 by 2, 1 by 2, 1 by 2. So what we can imply from this? Shall we say this equation is a multiple of 2 of first equation? When we multiply first equation by 2, this equation you may get. And that is a concept that when one is a constant multiple of another, we say they are dependent. We say they are dependent. This equation is depending on this one. If this doesn't exist, means this also not exist, is it? So dependent consistent. This one, how we can call it as? Dependent consistent. Then which one is independent and consistent? One does not lie on the other. One does not rely on the other. So this is independent consistent. Any doubts at this part? Do you have any doubts in this part? If so, tell me. Once again, see, we have seen only one linear equation represents one line. As pair of linear equation occurs, we have two lines. So the case of two lines has three possibilities, that it can intersect or parallel, or it may coincide on one another. When it will have what kind of lines, we don't know. For that we had a shortcut. We have a shortcut that using the ratio of the coefficients we can figure that out. Okay, that is it. Also, if it is unique or infinite, if it has solution, means it is consistent. So except this parallel line, we have remaining two as consistent. This one is not consistent. In consistent itself, we have two types. One is dependent consistent, another one is independent consistent. When we say depend on another, one is a multiple of another, means it is dependent. Simply, infinitely many solution comes, it is dependent. Okay. Unique solution means it is independent. Or else we can remember this in this way. Unique means single. It's an independent guy. We can't touch him. Infinitely many, cluster of people. Always the cluster of people depend on some other people. Okay. So when they say independent and consistent, unique, he is the boss. Here they are the employees. Cluster of people, infinitely many, they are dependent on another. Got it? Any doubts? Based on this, we'll work some questions and then later we'll discuss how to solve this kind of equations. Okay? Have finished writing, means we'll proceed further.